Welcome to Lecture 12.4, Applications of Integrals for Calculus for Business and Social Science. So today's lecture is really going to look at what we've learned throughout Section 12, Chapter 12, about integrals, and then applying them to some specific business problems. I don't know if I have any science problems, but I definitely have some business problems in here. So let's look at some things that we know, some basic things. First thing is we get, from a business perspective, that profit equals revenue minus cost. This is a basic formula that anyone at a college level should already know. I mean, you could also relate this to your own life. For example, the revenue or the money you have, the income you earn is from your job, perhaps, minus any costs in your own life. Your cost would be any expenses you have, food, rent, gas, etc. So if you take, let's say, your monthly income, your monthly paychecks, minus your monthly expenses, anything you have left over would be your profit. If this balance is negative, perhaps you bought groceries on credit, then you could actually have a negative profit, which means you're actually going into debt. So profit could be positive or negative. We tend to think of profit as positive, but a negative profit is really a loss. So the actual profit function can be positive or negative. We also know from earlier in this section, in this class, that a marginal for each of these functions, a marginal profit, marginal revenue, or marginal cost, can be found by taking the derivative of the function. So the marginal is telling us how each of these functions, how the profit changes, because it's a derivative, the instantaneous change. The marginal revenue is instantaneous change per item, or the cost marginal. Okay, and remember that the way we do this is that actually we'll talk about it in a minute. So we denote marginal profit here with MP with the line above it, and we know that this equals the derivative of the profit function. Marginal revenue we see here, which is the derivative of the revenue function. Marginal cost is the derivative of the cost function. So given that integrals are antiderivatives, we have the following integrals. So if I take the integral of the marginal profit, I'm going to get the profit function. The integral of the marginal revenue, I'll get the revenue function. The integral of the marginal cost, I'll get the cost function. So let's try this. Suppose the marginal cost function for a month for a certain product is equal to 3x plus 50, where x is the number of units and cost is in dollars. If the fixed costs related to the product amount to $10,000 per month, find the total cost function for the month. Well, it's asking us to find the total cost function. We just said that if we take the integral of the marginal, we will get the function, the original function. So let's integrate the marginal cost function to find the original. This is a very simple integral. Remember that we have the integral of a sum. We can take the integral of each piece. The integral of 3x is 3/2 x squared, using the power rule. The integral of a constant is just the constant times the variable, or 50x. And then remember we have the integrating constant. In this example, it's using a k instead of a c. Now, although this is the total cost function, we still have that constant in there, which really doesn't mean that we're finished. We really need to figure out what this constant is, because it could be a positive or a negative number, and that will throw all of our evaluation off. So we need to find out what that constant equals. Well, notice that they tell us the fixed cost is our $10,000 per month. Now, what does fixed cost mean in relation to our cost function? Well, remember, fixed costs are there whether we create something or not. So we can think of this as C of 0 equals 10,000, because our fixed costs are there whether we create something or not. So this is what we have to pay before we even start making anything. So if I plug this into our equation up here, I get C of 0 equals 10,000. I plug in 0 for all the x's. And so notice I get k equals 10,000. So now I have my total, my cost function by simply substituting in that constant. So my cost function is C of x equals 3/2 x squared plus 50x plus 10,000. And I've solved this formula, or this problem, for the cost function. So now I can figure out the cost for making any quantity of items that I want. An interesting thing happens is that if we set marginal revenue equal to marginal cost, usually this is the point where the profits are maximized. Now, it doesn't always happen that way, but it usually gives us the maximum positive profit. So let's look at a problem for this. So again, this is something you want to pay attention to. It's in yellow here. When the marginal revenue equals the marginal cost, this is a way of maximizing your profit. So given that the marginal revenue is this function, 400 minus 30x, and marginal cost is equal to 20x plus 50, and the cost of making 5 items is $17.50, find the max profit. Okay, so there's a couple things we have to do here. Obviously, we have to find the profit function. And remember, profit is revenue minus cost. We don't have revenue and cost. We have their marginal, so we're going to have to figure out their original functions. Not a big deal. We also want to find out where the profit is a maximum, and we were given that we could use the marginals to do that. And so we've got a couple things to do. So since we already have the marginals, let's figure out how many items we have to make and sell to maximize profit. And we do that by simply setting the marginals equal, marginal revenue equal to marginal cost. When we set these equations equal to each other and then solve for x, we get x equals 7. And you can do the algebra there. I'm not going to walk you through that. So we at least have a point at where the profit will be a maximum. Okay? At least we think we do. So the next thing is for us to figure out what the profit function is and then plug this value in so we can actually figure out what the maximum profit is. So first let's take the integral of the marginal revenue and subtract that from the integral of the marginal cost. Okay? So the revenue equals the integral of 400 minus 30x. There should be a dx there. That's bad notation on part of your instructor. Which notice is, again, a simple integral with two different pieces. We have the power rule, etc. So I get 400x minus 15x squared plus k. Now, this is kind of plugged in there quickly, but how do we know that r of 0 equals 0? Again, this is more concept. What is r? It's our revenue. If I don't sell anything, how much money do you think I'm going to make? None. So this is a very concept piece that you should know on the revenue side, right? If I'm not selling anything, I'm not making anything. So this is almost a standard. It doesn't have to be given in the problem. It wasn't. This is something you should know, okay? And since r of 0 equals 0, the k is also 0, right? So when we plug in 0 here, and solve for k, we get k is 0. Excuse me. If we want to find the cost function, we take the integral of the marginal cost. Again, another simple integral to solve, and we get 10x squared for the first piece plus 50x plus k. Here, however, we weren't given the fixed cost as in the last problem. We were given an interval value. It says that when we make 5 items, it costs us this, $17.50. So if we plug 5 in for x, we get 10 times 5 squared, which is 250, plus 50 times 5, which is another 250, and then set it into this equation, we get k equals 1250. And again, this is mainly algebra. All I've done, if this is c of x right here, then we plug in 5 and set it equal to 1750 and solve for k. So we have this. So our profit function, now be careful here, is 400 minus, here we go, 400x minus 15x squared. Remember, the k is gone. That's this part here, minus the entire cost function. So every one of these terms is minus. And this is where a common mistake happens. People will put minus 10x squared, and then they'll do plus 50x plus the 1250, which is the k. Remember, this is minus the cost function. So you would minus this whole function in parentheses and then distribute the negative. So h1 changes sign, and that's what we see here. And this simplifies to this formula here, 350x minus 25x squared minus 1250. Well, interestingly enough, this is a quadratic equation. And maybe you remember from, it's also the leading term, which is the x squared term, is negative, which means we have an upside down parabola or frown. And so the maximum is going to occur at the vertex of that parabola. Okay? It's very simple to find the vertex values by doing negative b over 2a. And this is in the wrong order. Remember, a, b, and c are the coefficients in front of the terms in the proper order from largest exponent to smallest. So negative b would be negative 350 over 2a. This would be the a term, would be 2 times negative 25 or negative 50. And interestingly, we get 7. So this is proving out that in this problem, this did indeed find when the maximum would occur. Now it asked us for the maximum profit, not how many we have to sell to make the maximum. So we need to plug 7 into this equation to find that formula. And so we plug in 7 and we get negative 25. So interestingly enough, we are not making a profit. We're actually at a loss because the profit function is still negative. So when we sell 7 items, we are actually losing only $25, which sometimes businesses would do that. Can you think of a time that you might do that? When you would sell at a loss? Maybe you're entering a new market and you want to be more competitive. You want to underprice your services or your items for someone else. Maybe you're new in a service area, and again, you want to introduce your company or your product or service to people. So again, you're doing it cheap. It might be just startup costs that until you hit a certain volume, you're going to be operating in a negative fashion. So there's a number of reasons why this may actually be a good term instead of a bad term. All right, let's look at another problem. Suppose that each week a company has a product with the marginal revenue equal to 200 minus 4x and marginal cost equal to 50 plus 2x. And the total cost of producing 10 units is $700. At what level should this company hold its weekly production in order to maximize profits? So interestingly enough, again, we're trying to maximize profits. So we need to find the max profit point, which is MR equals MC. Okay. Again, the marginal revenue equals the marginal cost will give us the unit where we find the maximum profit. When we set these two equations equal from the problem, we get x equals 25. So when we make and sell 25 units, we should be at maximum profit. So now let's find the profit function. P equals R minus C, we know this, or the integral of the marginal revenue minus the integral of the marginal cost. We can go through this again. It's very similar to before. So revenue equals the integral of 200 minus 4x. Very simple integral. Hopefully you've had some practice with your earlier homework and these integrals are coming along well. So we get 200x minus 2x squared using the power rule plus k. Again, remembering that if we make nothing, if we don't sell anything, we don't make anything. When we plug zeros in and that equals 0, we get k equals 0. We do the same thing for our marginal cost. We take the integral. We get, this is backwards, but I think I wrote it so it would look like a quadratic, x squared plus 50x plus k. And here again, we were given a value that when we produce 10 units, the cost is 700. We plug in those numbers, and if you plug x equals 10 in here and set it equal to 700, you can solve for k and you'll get 100. I'm not walking through those because those are basic algebra, and I'm trusting that you can solve for those. Okay, so our profit again is our revenue, you can see it in green, minus our cost where we've distributed the negative to each of these pieces. When we simplify that, we get negative 3x squared plus 150x minus 100. Now to find the max profit, we plug in 25 into this equation for x, right? Plugging in 25, we get the answer 1775. So our max profit is $1,775 when we sell 25 units. Now, unfortunately, that's not the right answer. And this is a big mistake the students often make. They're so used to doing a problem a certain way that they never pay attention to the question, or they don't pay enough attention. Let's put it that way. Let's go back to the question. At what level should this company hold its weekly production in order to maximize profits? So they're asking for production. Production is the number of units. Notice we had the answer at step 1. We didn't have to go any further. Of course, I did that so you'd get a little practice, but I also wanted you to pay attention to the question. Make sure you're answering the question asked.